we've had some beginning of these ideas and a good introduction from Andy and an overview from Ruben. And now I want to do something a little bit more dramatic. I want to start with these triads that Andy has talked about, and I want to connect them with physics. Okay? So what I'm going to do is I'm going to start with Swedenborg's ideas and expand them as Swedenborg did, and then I'm going to sort of reinterpret these and see if I can identify them with parts of physics. And then once we have the principles and once we can connect them with physics, then in the afternoon I'll show what we might conclude about what really happens in physics. And this is the purpose of today. So this morning I want to... If we go ahead, no. The what button? The on. Okay, on, yes. Okay, so we have the common pattern from Swedenborg that we've heard many times, and there's a triplet, a triad of spirit, mind, and nature, or celestial, spiritual, and natural. The heavens are three. The loving, thinking, and acting are a triad, and there are, in natural physics, we have principles, causes, and effects, or events. So there are lots of ways of seeing in the world of the spirit and in physics of this triplet of three things, one after the other. But the main principle is the fact that it's love, wisdom, and use is within each thing, because as Ron mentioned earlier, the divine is the same in things greatest and least, and so therefore each discrete degree, the divine is present in each degree of each one of those three degrees in the same way. Therefore, each discrete degree has sub-degrees of its own, and each sub-degree has sub-sub-degrees. So you can immediately generate an enormous amount of detailed structure of how this whole system operates, from the celestial heavens through mental activities into physics. And the purpose of today is to see if we can spell that out in detail and learn something that we didn't know before. And so I'm going to take... Oh dear. There we go. So I'm going to go from triads. First of all, I'm going from triads to enneads. And ennead is Greek for 9. So across the top here, we have love, wisdom, and use. But because the divine is present in each love degree, there's three aspects of love. There's love of loving, love of wisdom, love of use. So those are the three heavens of, the celestial heaven is the angels that love the process of loving, and the spiritual angels love the process of being wise and thinking, and the lowest heaven is the love of doing fair and useful things. This is a sort of potted summary of the three heavens. And then in the middle, we have wisdom about love. That's sort of the spiritual rationality, where wisdom about wisdom, or thinking about thinking, that's sort of what a good scientist does. And then we have 2.3 is wisdom about use. This is what a child does things and has to think about that. So I've taken the liberty of stretching the 6 degrees that Andy talked about into 9 here, because on the right we have the 3 natural degrees. The use that comes from love, that organizes the ends, use that comes from wisdom, which organizes the processes and stages of getting to the result, and then use is the final effect. So that you can see that once you imbibe the general principles that everything is composed of 3 discrete degrees, and everything individual of those is composed of itself 3 discrete degrees, we very quickly generate a more complicated plan, which I think follows on from Swedenborg's ideas, from the ideas in the writings. You would think that it had been done earlier, but I think, and everywhere in this grid of 9, wherever you draw 3 things in a line, then there's influx in that direction and correspondences between the 3. So there are vertical lines, there are horizontal lines, you can even draw diagonal lines, because influx happening all over that place. And whenever there's influx, the successive stages correspond to each other in the structures and functions that Reuben talked about. Now, the interesting thing is that the purpose of Theistic Science Group is to learn something about physics, to make some suggestions, some proposals for what physics can or should have known. And so the green on the right, the 3.1, 3.2, and 3.3, I'm going to dig down into those degrees and see what we can learn. So first of all, I have to understand what these discrete degrees are, these three shades of green. And so I'm going to, on the right there, in the middle, I've got a column called Swedenborg, which is the degrees that Andy showed come from Last Judgment, posthumous 320. The first one is the gravity, which is the first stage of setting up space and time, setting up the framework for doing things. And then the middle one is Swedenborg calls magnetism, and this last one is air. So these are the active elements in each of those 3 degrees. I mean, because air is the active element in this room, but there's also solids, so there are as well. So that those seem, as Andy pointed out, the beginning of these 3 discrete degrees from what is in the writings. So let's spell out in modern language, so to speak, because I want to eventually something like quantum physics. So the top degree, as I said, is making space-time. The middle one, we're going to generalize from magnetism and ether. We're going to generalize it to electromagnetic fields. Because we combine, these days, we know electricity and magnetism are really aspects of the same kind of field. And so this follows on. These are all within the 1 degree. And now I'm going to include every field, quantum fields as well, because quantum fields are the gluons and the mesons and all of these. Each kind of particle that Andy had on his list is a particular quantum field, and so this is all part of the standard model. So all of those things are their individual kind, but all of these things are in the middle degree. But the bottom one, which Swedenborg called air, I want to say is not just air, but everything that we see in the room. For instance, every solid thing, including the sun, with nuclear reactions. These are particular objects that we can see, and I include both quantum and classical objects, because quantum and classical objects are really the same thing. The quantum physics is just a better way of describing how things behave that we might think of as classical. And so physics at the moment understands the physics of objects, the 3.3 line, the lowest line, and it understands about quantum fields. Quantum field theory has been developed since 1945, a bit earlier, and it works quite well. There are some problems, which we'll come to. But this first degree is something that is still unknown, still mysterious from the physics point of view. Physicists know there must be something like making space-time, but they don't know what it is. And so there's a gap there in our understanding. But before we go into exploring that, I want to discuss the fact that there's immediate and mediated influx. So, and because if we have this quote here from Swedenborg in 7270, there is God's truth flows into the third heaven nearest the Lord, and at the same time flows right down to the last and lowest degrees, without undergoing degrees of formation. So if we go to draw a picture of this, we have the divine at the top in red, and on the right we have the orange lines, yellow, orange, the immediate influx which goes into the physical discrete degrees there, the green degrees. So this is the, what was the first? The active force is the presence of the Lord in every place, and it sets up the framework for everything. So this is what Reuben would call intelligent default. It sets up the nature of things such that they can be organized into a human form. But as well as what Reuben called intelligent default, there are also specific intelligence, intelligence specific as well, which comes through intermediate spiritual beings, of the spiritual beings in the grand man and the spiritual beings in our own mind. And after Andy, I'm going to say that every animal has a spiritual life of its own. So where I got to our mind, I should include the spiritual form that comes from the angelic heavens, and is a particular desire or affection or thought that is then also by the blue lines enters into nature. So there's two things entering into nature. There's not just the intelligent default that sets everything up on the orange, but there's specific intelligent and affectional input via the blue lines. And these vary with time, and they manage the randomness. So things that might appear to be random are normally organized to do specific things, or most of the time. And so there's two kinds of influx. And the purpose of today is to focus on what these blue lines do in physics. So it's after Steve talks about biology and its problems, I'm going to make a proposal later in the afternoon for what the blue lines, what effect they have when they get into 3.1. Because the 3.1 where the formative, okay, so the active force is the orange lines on the right. The middle one is creative force, which comes through the spiritual heavens, the blue lines. But once it gets into 3.1, there's a formative force in nature which organizes the forms of things in nature. So that's what this whole day is about. It's understanding what this formative force in the finest things in nature. Because you remember in Swedenborg he talks about the limbus as composed of the finest things in nature. So what we're doing today is making a proposal for what the limbus or the finest things in nature might be, the 3.1 degree. Because 3.2 is quantum field theory and 3.3 is ordinary physics of objects. Those are quite well known, except we're going to have to modify them a little bit. So 3.1 is the gap where we're trying to put in something which connects them all in a way which you would expect from correspondences. So we're using the idea of correspondences. This 3.1 has to act like a love of ends, and the middle one, 3.2, acts like the operation of means, and the 3.3 acts like the operation of the final effects. So we know what that pattern looks like, and so we have to find a general, specific details of what's happening in 3.1 in order to do that. But now you say, we might remember I said everything has 3 subdegrees. So these sub-subdegrees actually have sub-sub-subdegrees. So up the top I have the 3 degrees, the 3 natural ones. And now I've split them into 9 themselves. So these are 1/27th of the original whole system, starting from the celestial heaven. So 3.2 is now the middle row there. It has a Lagrangian, which contains all the coupling constants and all the fields. And the Lagrangian, when you apply a least action principle that Andy talked about, tells you how the fields that propagate out through space and time into the future. And then 3.3 is the result of the quantum fields acting, which sets up the masses and the interactions, the electric and magnetic forces, nuclear forces, weak forces between all objects. And then 3.3 is where you have masses and potential energies, and you follow the motion of individual particles using Schrödinger equation, which has a Hamiltonian in it, and it produces the wave function, and then the wave function acts to make, in something like measurements, actual selections, which is sort of the bottom line of the whole process. This is the end, the fixed containment at the end, which keeps everything constant. Because, as Andy said, the purpose of the natural degree is to form a containment that renders the bird permanent, at least while it's living. But it lasts longer than after the angel stops thinking about it. So at least it has to live long enough to propagate, reproduce. So this whole framework of 9 degrees within the physical sub-degrees, I think follows on from Swedenborg's principles. So Swedenborg didn't actually say these things, but having read Divine Love and Wisdom and trying to understand the principles which would lead Swedenborg to write the Divine Love and Wisdom, I think we can quite plausibly argue that there are sub-degrees like this, which then we can understand, we can read in from what we know about quantum physics. You have to learn quantum physics first, because I started to learn Swedenborg at the same time as I was learning quantum physics for the first time. So for the last 40 years, so to speak, I've been learning them in parallel. And so Swedenborg has helped me understand quantum physics in this ways, and quantum physics has enabled me to spell out what sub-degrees could be. And so it's given me some confidence that this track is a reasonable one to follow. I want to discuss these 3.3, 3.2, and 3.1. I'm going to discuss what we know and what we don't know about those, because we're going to build on this information later in the afternoon. So let's read from the bottom first. I've actually read some of these things. I don't mind, Andy. So the 3.3 degree is the physics of individual objects. So molecules, atoms, quarks, nuclei, organisms they're seemingly well understood because we can use quantum physics. And when there's lots of quantum physics, the quantum physics parts is not so important. You can treat them quite accurately with classical physics. So you have forces on masses. There's still a little bit of puzzle about the measurement problem. This very last step, the very bottom right-hand corner, the bottom line. People not quite sure in physics when it occurs, and so you might have heard about the measurement problem in quantum physics. But from Swedenborg's point of view, the whole point of nature is that you do come to an actual selection of something definite and specific which forms the history. Your past life is the set of all those bottom lines, all those final decisions that have happened in the past, and the past is definite. So from Swedenborg's insights, and also when we apply his principles, we have an ultimate action, a 3.3 degree that does have something like measurements. We can't just ignore it. And so, but now we come to probably what might be new to some of you, most of you, is this middle degree 3.2, which, from Swedenborg he called it magnetic fields and ether, so I call it electromagnetic fields. Then I said also gluon fields, and in fact all of the fields there. I point out this generates the forces that act between the individual objects. So quantum field theory is a discrete degree above the physics of individual objects that last for a long time. And so, and the ingredients of this quantum field theory, if we go back a little bit, is this Lagrangian. I mentioned Lagrangian, and I said it's the principles for quantum fields. But Lagrangian is a mathematical form that you integrate over all space and time, and it has the fields and their coupling constants because the fields interact with each other. So the photon field interacts with the electron field by a constant which is the charge of the electron. So that's the coupling constant between the electric field and the photon field. There's another coupling constant between the Higgs field and the electron. That's responsible for producing the mass of the electron. The proton has also, as well as electric and mass coupling constant, it also has coupling to the gluon field. That's the strong force which keeps it in nuclei. So the Lagrangian sets up all of these coupling constants. And if you look up Wikipedia about the standard model, if you look, the standard model is this. So people have written down all of the Lagrangian for the standard model. It has all these coupling constants spelt out, and that defines what the Lagrangian is, which explains nearly everything that physicists measure with their equipment. There's a few things that are out, like masses of neutrinos, which are puzzling. But nearly all of the standard model is extremely well verified. So the coupling with the electromagnetic field gives charge, the effect of electromagnetism and electrostatics and magnetics. And the coupling with gluons gives power, hard force. The coupling with the Higgs field gives the masses of everything. So that all seems to work quite well. And as I said in my summary, that it's determined by a Lagrangian with coupling constants. And I'm just spelling out this business about coupling constants because I'm going to do something in the afternoon. I'm going to fiddle with the coupling constants a little bit. Because the coupling constants are the input to the Lagrangian. So you would think that if there was a 3.1 degree on top, then it would control what goes into the Lagrangian, because it manages, it gives the ends for the Lagrangian. So it's going to do something with these coupling constants. So you'll find out later on today what it actually does. Now, and the reason I'm picking on coupling constants is that there's actually a problem with coupling constants in quantum field theory. And now I'm going to go into a little bit of physics, which you don't have to follow in detail, but just to say that ordinary quantum field theory is not quite as simple as I've made out so far. There is so there's a little bit of trick going on, which I'll try and explain. Because the quantum field theory, the coupling constants in the Lagrangian are what we call the bare interactions, so the bare charge or the bare mass. But then when you calculate all the possible quantum fields, which explore all possible options into the future, you'll discover that as well as the interaction between a photon, which is the gamma, and an electron, there's all these other little processes which are also possible with some small probabilities. And quantum field theory it gives you the rules for calculating all these extra effects. And then so when a real photon acts with a real electron, it interacts by means the sum of the bare coupling on the left with all the possible multiple scattering events that we have in the middle here. So that means that the electric charge that you actually see in nature is not the charge you put into the Lagrangian, but it's something which is the sum of all of these results. So that means, so if a physicist wants to make a prediction, he has to adjust this input one such that when he does the calculation, it comes out with the observed number. So that the normal electric charge that we know, 1.602 times 10 to the minus 19th Coulomb, is not something that you put into the Lagrangian or the field theory. No, it's the number that we get from the experimentalists, and then we have to, depending on how much calculation we do, we have to work out, we have to fiddle with our results in order to make the calculations come out of that number. And so there's a tuning process, an adjustment process. So in blue here I say, we adjust the bare interactions so that the dress charge agrees with the experiment. So there's a hint of a tuning process here, but it only has to be done once, because once you work out the charge, the dress charge, which is what you observe, it's made to come out right, and that's for the whole universe. So you only have to do it once, and you only have to do it for the masses of the fundamental particles and the coupling constants. So there's about 6 or 8. Actually, the six quarks, their masses, and the gluon coupling constant, and it's about 10 particles, 10 numbers have to be adjusted in order that the results come out right. It has to be a tuning process when the quantum field theorists the results. Okay, but they've got used to that now. They've done it for the last 50 years, and the amazing thing is that if you adjust these 10 or 12 values, then they can make lots of other predictions which come out amazingly accurate, like the magnetic moment of the electron comes out to 12 decimal places. So they're happy that they're on the right track. But at the beginning, they still had to do this fiddling process to make sure the numbers come out right. They didn't put the numbers in that they want to end up with. So they have to do the calculation, then work around a loop. So the question is, I think this is just a summary of what I was. Yeah, I tend to jump ahead. This process of adjusting the input to get the right output is called renormalization. And It happens all the time. Whenever I do a quantum physics calculation, there's always a renormalization issue. So physicists are used to that. They have to there's various ways of doing it, but it seems to work remarkably well. And so I say at the bottom, maybe there's a tuning or a fine-tuning process which adjusts inputs to give the observed output. So that's the message I want you to remember from this morning, and that there is even in existing physics, ever since 1950, say, when this renormalization process was discovered, there's a tuning process even in standard quantum field theory. So I'm going to summarize by making a list of the physics that we don't understand at present. These are the open issues in physics these days. So there's the 3.1 degree and gravity is still a big problem, because what describes gravity quite well is Einstein's general relativity. But this has nothing to do with quantum physics. So there's a big general relativity has a completely different foundation from quantum physics. But they haven't managed to find a way of combining them. If there was a way of combining them, then because it would surely be a 3.1 degree. And that's where our theistic science group started off, trying to find a way of thinking about gravity and space-time such that it would fit in as the operation of the 3.1, because no one knows at the moment what 3.1 degree does. But then we branched over to, so gravity is like the active force, but we branched over to look at the formative force, which is, where we'll talk about the results. So these are the gaps. So the gravity is an unknown problem. Quantum gravity, there's a lot of people working on quantum gravity, but they haven't got very far. There's this question of renormalization. Renormalization is quite easy on the whole, except some renormalization, such as for the Higgs mass, is extremely difficult. You have to do a calculation to enormous precision. Okay, I'll finish before that. So you have to do a very difficult calculation, and that's called I say it's a hard problem. So physicists call it the naturalness problem. So if you ever look up what the naturalness problem is, it's the fact that you have to, adjusting the Higgs mass, adjusting the inputs to give the correct Higgs mass is an extremely difficult problem, and they don't really try to do it because you need about 40 decimal digits in your calculation, and no one believes their calculation to that accuracy. But for quark masses, electron masses, unit charges, that's a bit easier. And then at the end, the last thing, of course, is that no one knows from the physics point of view how to link the spiritual within the natural. So, but should we try?